Welcome to Lifecycle Talks, a series of talks presenting the research front to keep you up to date with the science and application of the lifecycle perspective. Today's Lifecycle Talk is How Can We Shape Sustainable Digital Futures, where we will learn about challenges in assessment of environmental impacts of digitalization and hear some recommendations for assessments of the global information and communication technology sector's climate impact. My name is Maria Rydberg, and I am very happy to welcome our guest for today, Anna Furberg, a researcher at the Department of Sustainable Development, Environmental Science and Engineering at KTH, and also affiliated with KTH Digital Futures. And before we start, I will just give you some practical information. All of Lifecycle Talks will be published and made available on the Swedish Lifecycle Center YouTube channel after this live event has ended. And we will not use the raise hand function in Lifecycle Talks, but please feel free to submit any questions that you have in the Q&A function. And we will also make it possible for you to upvote other people's questions. And during the Q&A sessions after the presentations, we will select a few questions to address from the Q&A. But I will start with a warm-up question for you, Anna. I am curious, what motivated you to begin exploring this area of research?
Yes, so I want to contribute with knowledge on how we can move towards a more sustainable society. And digitalization is really transforming our society, and we need to steer the use of these technologies. So then it's really important to understand its environmental impacts from a life cycle perspective. So I find this very interesting and rewarding to work with.
Thank you very much, Anna. Now it is time for your life cycle talk.
Thank you, and thank you for inviting me. So, how can we shape sustainable digital futures? There are high hopes that digital technologies will contribute in solving some of the critical challenges that society faces today. And digital transformation is really changing core economic sectors like transport, energy, buildings. We can have process optimizations where you increase energy efficiency or replace physical products and thus potentially reduce resource use. But this technology also comes with a cost, and researchers have raised a call for a digital reset, stating that environmental and social impacts of the information and communication technology sector, that is the ICT sector, must be reduced. And then on top of all of this, we have the wild card of artificial intelligence, AI. So these AI applications, they can both contribute to increased but also reduced impacts in other sectors. So in summary, the ongoing and rapid digital transformation of society, exemplified by significant investments made in AI, for example, and data centers, have led to concerns for increased future emissions from this sector. And to inform decision makers on different possible trajectories for the ICT sector, it is important to apply a life cycle perspective. And the ICT sector, consisting of end user devices, computers, smartphones, for example, networks, for example, fixed and mobile access networks, and data centers, servers, for example. This sector or direct climate impacts of this sector occur along the entire life cycle of ICT, including raw material acquisition, production, use, and waste management. And then the question is, what is the potential future climate impacts of this sector? And there are previous studies here in this table showing three commonly cited studies that have received a lot of interest in media. They typically arrive at contradictory results for future climate impacts. And some of these scenarios, they resulted in significant increases for future direct climate impact of the global ICT sector. Other scenarios estimated that it will slightly increase or remain fairly stable and even decrease in the future. And of course, this is 3 commonly cited studies. There exist other ones, but in the study that we have conducted, we focus on these 3 because typically other studies lacked detailed descriptions of calculations or background for their studies. So I will focus on these 3 studies. And so these contradictory results, they sparked our interest. So what are really the reasons behind these contradictory future projection results in these studies? So to try to understand this, we conducted a critical review for these and reconstructed the results from these studies for the year of 2020. That was the only year for which the studies shared future projections. So we reconstructed the results applying an as high level of detail as possible, and then scrutinized these results, focusing on the calculation approaches and the strategies applied for future scenario construction. And importantly, we wanted to see what is actually comparable between these studies in terms of scope, and to try to understand differences in terms of model and parameter uncertainties. So what we found was that the main reason behind these contradictory future projection results are due to model uncertainties. These studies apply a quite different definition of the ICT sector and different coverage of life cycle stages. So in fact, the comparable parts were only the use phase for 3 specific end user devices: computers, smartphones, and tablets, and the use phase for networks and use phase for data centers. So a quite small part of the ICT sector were actually comparable over these studies. Still, these parts were responsible for a larger share of the study's total results for the global ICT sector, at about 60 to 80%. Then the remaining parts were incomparable, either due to difference in scope, but sometimes also due to a high aggregation level in the results that prevented comparisons of parts. And when it comes to scope, for example, one of the studies included TVs in the scope for the ICT sector, which contributed quite a lot to the impact. The other studies didn't. So there were some concrete differences. Then we also could see that in practice, only one study model applied strategies for future scenario construction and digitalization trends that in practice allows decreased emissions by considering future electricity efficiency improvements. So in the other studies, for example, data centers emissions are bound to increase in the future. That was also true for the use phase of networks, but this was not really clearly motivated. We also compared these reconstructed future projection results with an estimate for 2020 based on a study from Malmedin et al. Published in 2024, where they partly used measured data from data centers on their electricity consumption, for example. And our results show that these future projections, they tend to be significantly larger than the estimate, and especially true for use phase of data centers, where the future projections were 120 to 620% larger. And this indicate the difficulties in making future projections and also underline the importance of transparency and acknowledging uncertainties, for example, via different scenarios. Then we also could see several different critical aspects. For example, fast-growing and emerging digital technologies were typically not included in these studies, despite that they might emerge during their temporal scope, the temporal scope of the studies. And only one study made changes to the carbon intensity of electricity generation in the future. So in practice, the studies model the current and future electricity systems to be the same. And none of the studies included stocks and flows and all life cycle phases of the ICT sector and its subdomains. So to some extent, then underestimating the climate impact. So when we had finalized this work, we saw that this indicates a need for guidelines for future studies on how to quantify the direct climate impact and energy use of the global ICT sector. So that led to the work with and development of a guidelines paper. So in October 2023, we had our first workshop and then 3 subsequent workshops that led to the joint writing of a guidelines paper, including in total 15 researchers, both from academia and ICT companies. And this paper summarized the state of art in practice and related challenges, provide guidelines, and provides a set of key aspects, recommendations on key aspects in influencing the global ICT sector's direct energy use and climate impact. And that is what I would like to show you now. So given the 3 different subdomains of ICT, here first the end user device subdomain. So key aspects here are really the number of devices, what are the shipments, is the installed base of these devices, their annual electricity use, embodied emissions, and the lifetime. So how long time are these products used? And to the right, you can see some suggestions on units for these key aspects. For networks, if you see the end user devices is more like a bottom-up approach, where the number of devices and then you estimate the impact. For networks, we saw the need of a more top-down approach. So here you need information on the number of subscriptions to these networks, to the network. Networks can be many different things, different types of networks. Annual electricity use per subscription and year, embodied emissions, and the lifetime of these networks, which is quite longer than for end user devices then. And for data centers then, a more bottom-up approach where you look at the number of servers, shipments, and installed base, annual electricity use, power usage effectiveness, that is to consider that in data centers you need a whole infrastructure around these servers, for example, cooling, and the lifetime. And last but not least important, the carbon intensity of electricity, which of course will influence the impact from all of these subdomains. And so these key aspects reflect the current pragmatic calculation approaches for these ICT subdomains, but in general, it's recommended to combine approaches, both top-down, where you maybe have measured electricity for data centers, with this bottom-up approach. And we also provide some general guidelines for these future studies. So for one thing is that when we're talking about predictive scenarios that builds on current trends and try to extrapolate them into the future, these types of projections are only meaningful up to about 5 years into the future, because of the rapid technology development and disruptive technologies like AI. After that, you need to have other types of scenarios, such as explorative ones. And also you it is important to have a high level of transparency and disaggregation so that you can see what can be compared between different studies. And here are all the authors of this paper. So I wanted to show you that. I also want to say something about fast-growing AI, which were typically not included in the previous study's future projections. So when we talk about AI and energy use in the global context, it is perhaps currently not that large. There are studies stating that it's probably only a small share of the global electricity use, but it is still significant. This is a picture from a study from the Lawrence Berkeley National Laboratory, where they looked at US data centers, and they could see that their electricity consumption more than doubled between 2017 and 2023. And the main reason for this, they state, were the increased use of AI and the advanced servers that are required for that. And it should also be remembered, of course, that challenges might be huge locally. In Ireland, for example, data centers are responsible for, or in 2024, they were responsible for 22% of their electricity, of their total electricity consumption. Quite a lot. And then when we talk about the future, a paper in Nature states that the demand for AI services is expected to rise by 30 to 40% annually over the next 5 to 10 years. So a high demand is expected for AI services. And if we go back to this study on US data centers, they estimate that they created future scenarios. You can see the gray area here. So the scenarios is different depending on technology developments like energy efficiency improvements and type of cooling technologies. But their scenarios show that the data center electricity use in the US might be 7 to 12% in 2028, which is quite soon. Furthermore, AI can lead to both increased and reduced impacts in other sectors. So we need to understand how we should use AI and for what. And furthermore, of course, we cannot only think about energy use and climate impacts. There are many other impacts that we need to consider for AI and for digital technologies in general. So when we arrive at this point, you might wonder then, well, where are we heading? What can we do? How can we shape sustainable digital futures? And what we do know is that the future is inherently uncertain, but that also leads us to understand that it's really important to try to understand the uncertainty and to construct different types of scenarios that answer different questions. What if this happens? Or what if we want to reach this target? What could happen? And to look at a broad range of solutions. And also importantly, future decisions will contribute in shaping the future. So many actors have a responsibility here. Decision makers, politicians in steering how we use technology, rules for that, industries in how AI models are developed, for example, and we consumers, how do we use the technology? Do we need to use it for everything? And researchers like me to generate knowledge to support decisions. And the Dublin, Ireland example, it didn't happen by chance. So incentives were put in place to make it attractive to invest in data centers. So there are things that we can do here, decisions to make. So what I want you to bring home from this talk is that the life cycle perspective on ICT really has an important role in informing future decisions towards sustainability. And digitalization can lead to both increased and reduced impacts in other sectors, and we really need to consider both. as well as other types of environmental impacts. So there are still a lot of things to be done in this research area, and one thing you can do is to submit your contributions to an upcoming session at the CETAC conference. So you're very welcome to submit your proposals. Thank you very much.
Thank you very much, Anna, for your very nice talk. I enjoyed it a lot. Now you can post your questions to Anna in the Q&A function in the Zoom window. But until you have had time to do that, I will start off with a few questions from my side. And let's start with you talked just in the end here about other impacts than climate that are also important to consider for digital technologies. Can you give some examples?
Yes, so one thing is the raw materials needed for electronics. So ICT hardware is dependent on a lot of materials, almost covering the entire periodic table. So base metals, scarce metals, also conflict minerals. So resource impacts is important to consider for digital technologies. Another example is water use, which has gained a lot of interest or focus when it comes to data centers, water used for cooling. In the production of electronics, there are sometimes quite harsh conditions, health, security problems, excessive working hours, so also social aspects there. And when we talk about the end or the waste management of electronics, it is difficult to recycle due to these low concentrations of many different metals in electronics. But there is also issues with informal e-waste recycling. So electronics ending up in a pile somewhere where people try to pick out parts. And that is, of course, health impacts related to that. So that was some examples of other topics.
Thank you. And you also mentioned the importance of considering that digital technologies both can lead to reduced and increased impacts. Can you elaborate on that a little bit?
Yes, so as I said, ICT can be a part of the problem, but also part of the solution. So we have the direct impacts from producing, using, and waste management of this technology. But then, depending on how the technology is used, it can it can have, for example, optimization effects in industry, reducing energy use. But digital technologies might also induce more consumption. For example, you have your computer, you have internet connection, you can order things almost all day around. So there are a lot of indirect effects in how we apply this technology, and there is also something called rebound effects, where if efficiency creates additional demand, because if you have an increased efficiency, that can lead to cheaper products, and then that might lead to a net increased consumption because things became cheaper. And when it comes to AI, for example, the indirect effects have been stated to, they might vastly exceed those from the direct impacts. So these indirect effects where the use of technology leads to increased or reduced impacts in other sectors, that can really be extensive for AI, but also for other digital technologies. And to make a fair assessment of these technologies, you need to consider both. You cannot only look at, oh, what are the opportunities or what are the challenges? You need to consider both.
That sounds reasonable, I think. And what are the challenges for prospective LCA of information and communication technologies?
Yes, so assessments of the future is always challenging, but prospective LCA of ICT, I would say, is especially challenging due to this very rapid technology development. And that one challenge is the high model complexity due to this rapid technology development, disruptive technologies, but also the interdependence between products and services like AI and their infrastructure, that is networks and data centers, as well as hardware and software. So if you make changes in network technology, that will affect end user devices and data centers. So this is interconnected. So you really need to have a life cycle perspective and a holistic perspective. And then on top of that, you have the indirect effects that we have talked about that can lead to both increased and reduced impacts in other sectors. And this really put requirements on LCA practitioners. How should we deal with the future? What type of time horizons and what type of scenarios should we construct and how?
Yeah, sounds like a real challenge.
Exciting challenge.
Yes, of course. Did you identify preferred strategies to deal with the multifunctional possibilities of the ICT devices and services? For example, the studies considering that the functions of the ICT sector might have changed over time or might change over time.
Yeah, so if I understand correctly, the question is related to the challenges with multifunctionality of ICT devices. And yes, it is challenging. A smartphone can be used for many different things. For example, you can use the internet or you can talk to someone and so forth. There are strategies trying to handle this. One thing could be to look at at user behavior. So how much time do you use the smartphone to send messages? How much do you use it for social media? And then you can try to allocate impacts to a specific use depending on, for example, then the hours spent with a specific service compared to the total hours of use of this device. But there are, of course, many different strategies, and you need to look at the specific device in question then, of course.
And to go back to the functions of ICT and AI, while they can cause emissions, they can of course also be useful. Are there studies on impacts per function?
So impacts per function meaning for example, like a per prompt or that is not stated.
No,
No.
unfortunately not. But you can interpret that as you wish.
Okay. Yes. The most studies I've seen, they try to understand what is the impact of training AI, using AI. Some looking at a more life cycle perspective on this model, on the baseline of this model. So I don't have a concrete example there, but there are. Or maybe I can mention an example from an own study that is currently under review. But there we look at the function of providing radio or a generative AI radio station, providing that to the listener. So that is more on function base. So those type of examples exist.
Thank you very much, Anna Furberg, researcher at KTA, for your talk. I will now wrap things up. And if you are interested interested to know more about Anna's field of research, you can read more about the project that she is involved in at the moment. And on the next slide, there is a list of publications that is a good start for further reading. And all of these links that I have shared in this presentation can also be found on the Swedish Life Cycle Center website in the calendar event for this talk. And Lifecycle Talks are published by the Innovation Cluster for the Lifecycle Perspective and the Swedish Cycle Center. Thank you everybody for listening and for asking questions. Our next Lifecycle Talk will be in June, on the 15th of June, and it will be about sufficiency LCA. And to not miss the invitation, please follow Swedish Lifecycle Center on LinkedIn and feel free to subscribe to our newsletter to keep you up to date with the Lifecycle Talk and our other events and information.